it comes to computer science, introverts generally get the speaking roles. Just a bit of background about me. I'm the chairman of UCC NetSoc this year. I'm a third year in computer science, and I actually have to look at my own notes to remember my own history. I've been doing web development for the last 6 years, and I've worked on large and microscopic projects. I've spent a lot of my life dragging companies into the 21st century, kicking and screaming. Ever since I've come to college, I've taken a keen interest in security because, to be honest, when you give your application to 80-odd trigger-happy computer scientists, it becomes very important that it's secure and, doesn't leak everyone's information, such as mistakes I've made. You'll notice me stop it there a lot. I'm very sorry. But the format of today is very much going to be, I'm going to speak for a while, I'm going to switch to a web panel, show you an actual implementation of things. And if you have any questions, you can ask questions during these kind of weird beige slides. They're a different color to all the other slides, or there's Q&A at the end if you have any questions. I understand that quite a lot of people just don't ask questions and stand here awkwardly being judged silently. And I'm kind of okay with that. It's a thing of mine. To begin with, injection is the process of triggering an application into including unintended commands in the application's execution. So you're jamming something unexpected between the system and the user. Well, what I'm going to use as an example today is SQL injection, because it's just the most basic form of injection. For those unfamiliar with SQL, it's mainly a database language. It's used to read and write to databases information, and it follows a very kind of English-like syntax, so it should be easy enough to kind of get your head around. But I'm going to try and avoid using or talking specifically about code. I'm going to talk about it on a very much high level, even though there will be code samples for those of you who are interested. So one of the most kind of common things these hacksaws target first is whatever system uses to authenticate users. So if they can get between the authentication system and the user, then they can impersonate or hijack any user's account. This is a very basic example of how authentication is done. What you're essentially doing is you're passing a username and a password straight into what is a query here, and you're just checking to see if it exists. And if it exists, great, you let the user in. If not, well then you tell them they fucked up and you put it back again. Just to isolate the kind of SQL part of it, this is solely what it looks like in SQL. So you're grabbing all the information where the username is equal to Evan and the password is my password. It looks pretty okay, doesn't it? But there's an obvious flaw in this approach to it. What we can do is we can actually hijack that password field and specifically put in anything we want. So with a little bit of SQL knowledge, we can hijack this entire query and log in as anyone we want. Specifically in this case, we'll probably be logging in as the Evan user. But I'll show you a demonstration in a moment where I log in as admin, just in something we made ourselves. So what you can do is, this is just kind of an example of us injecting some code into it. So what I've done is I've closed off the query and given a true statement. And I'll explain that there in the next slide now. So the kind of main flaw in what this is that true always equals true. And that if you can put something in a query where it always equals true, then you can effectively trick the system into doing anything for you. It's starting to rain weirdly. I also speak to myself a lot, and hope you don't feel put off by that. I'll also whisper to you to make sure you're involved. The famous example of SQL injection is, if you haven't seen it, an XKCD cartoon involving little Bobby tables involved. So what happens when we put Robert quote bracket semicolon drop table student semicolon dash dash into the student database? The school would later go on to liken this incident to World War II, I imagine. So what we can do is we can break it down into 3 easy steps. I mentioned them very briefly there when I was showing you our code, but the first step is we need to close the query. So what we've done is we put in Robert apostrophe bracket semicolon, and that finishes it. This is specific to the language, so you don't need to know that much about it, but just know that you have to close off the original query. The second step is that we're going to execute our malicious code. So in this case, we're going to drop and delete the table students, the entirety of it, regardless. And then what we're going to do is we're going to comment out the rest of the code to make sure that we don't cause an error that they could either detect or break our execution. It's not all doom and gloom. In fact, it's quite easy to prevent SQL injection. Some of these will look very alien to you, and to be honest, they still kind of look a little alien to me. But you can bind variables to specific types of attributes. You can prepare statements to make sure that they know exactly what they're expecting. Yeah. So if someone starts putting a puppy in as your password, you can tell them to go fuck themselves. Another method is to make sure that your SQL user has what's called the least amount of privileges necessary to execute its task. Not doing that is very much like giving a nuclear reactor to a coal miner. If you're just reading like simple data from it or inserting like a couple rows or anything, they don't need access to absolutely everything your system has to offer. And quite frankly, it would be idiotic to give them the keys to the car, so to speak. In conclusion, I haven't written this down, but to talk about injection, it's very much like, think if you have a black box and it does everything for you. It does absolutely everything for you. It cleans your clothes, it washes your house, brushes your teeth, it feeds your pet, and it remembers to feed Timmy the goldfish on Tuesdays but not on Thursdays, and only on Fridays if it's a full moon the next day. Things like that. And it's on that little black box is a tiny, tiny little hole where you put in the name of your black box, and you name your house, and that's how you customize it, and that's how you sell it. And it's like taking a massive brick and just smashing your way through that tiny hole until eventually your black box doesn't exist anymore. And then what the hacker does is they reassemble all the little pieces into what they want to do. So they exploit the entirety of the system to either gain information from it that's already there, or present spoofed information to try and lure you into giving up more. Yeah, I forgot I haven't did that yet. So cross-site scripting is kind of very similar to injection, but instead of us trying solely to manipulate the system, we're going to exploit the system to exploit the user. So we're going to trick the user into giving us more information. I'm going to speak specifically about 2 types of cross-site scripting. One is reflected and one is persistent. Reflected just means that when you put something in, it's reflected back at you and you can see it, you can see the result. But persistent means it goes into a database somewhere, and that's very dangerous because everyone sees that. Like, imagine if someone could inject something into Twitter that launched a pop-up and asked for your username and password. You wouldn't be any of the wiser. You're on Twitter, obviously. The damage that can come from cross-site scripting is some of the worst, because it deals solely in the information. You can hijack the user session, so you would be acting as that user for the remainder of your time. You could deface a website, or even easier, you can just set up redirection to anywhere you want to go. I mean, have any of you seen Blue Waffle or Meatspin? Imagine if you logged onto Google one day and Google was just Blue Waffle. For some of us, it is. Yeah. So reflective CSS, or reflective XSS. CSS would be something different. So the concept here is that we have a little search form, and it's a library. We want to look for a book. So all you're presented with is a tiny little form on a page, and you log on, you type in the name of your book, and that's great. So, but we're beginners, so we'll make the code a little neater, and what we'll do is we'll just take the direct input someone is given from us and just put it back out if there's not if there's no results. So you'll put in Hemingway, and it'll come back with, sorry, there are no results for Hemingway. I'm going to switch out in a minute there now. So this is actually a physical form, so I'll show you the demonstration of that. So we can easily test the form by just putting in a couple of HTML tags. And like, if you're unfamiliar with HTML, you can Google it and you'll get examples that you can just paste right in and see if there's any kind of rendering or response from it. So in this case, we're just underlining the word sanitize me. There we go. And it's actually this way. So here we have our form. And as I said, we're just going to simply change it by underlining the words sanitize me. Yeah, it doesn't matter. So you can see that it came out with an underline. But we can do that with any tag. So we can make that a link. So I'm actually just not going to link to anything. I'm also used to a Mac, so this is horrible. Yeah, so now it's a link. So this is really poorly sanitized. Like, you can put anything in there, as we will. Like, I can't drive home the importance of sanitizing your inputs and making sure that none of the code that other people enter gets rendered on your web page. Because I know collaboration is the in thing right now, but open sourcing every form on your web page is probably the worst thing you can possibly do. It's rendering our code, it's rendering our query essentially, and that's just sinful. So what we can do is we can put in JavaScript, and this is a little bit more dangerous then, because we can get programmatic code to execute on their side. So this is just a confirm dialog. It'll pop up with just OK, and you continue on. But again, imagine if you could put a login form on that. Like, again, I'll use the example of Twitter. You log into Twitter and ask for your login information again, and you're a little confused. But again, you're on Twitter. You've done it a million times. Why wouldn't you give them your username and password? So actually, I can just show you how that works. So, like, you can get so much information just from that alone. Using JavaScript, you can get all sorts of metadata about the browser. You could hide a script on a page that collected all this information and put it in a server somewhere, and then actually sell that data to an advertising company for millions, probably, depending on what site you're on and how many users you had. So malicious isn't necessarily all about actually harming the user or defacing a website. Sometimes it's just about information gathering in the background, hidden to anyone. And as a website owner, you probably wouldn't notice this for quite a long time. Like, unless you had very sophisticated error reporting, you probably let this just go unbeknownst to you for months, maybe years. I know I've had applications where I built when I was 16, and I've come back to them 2-3 years later, and they're filled with spam bots advertising Viagra and shit. And I was 16, I didn't need my address. So they've given us a nice little pop-up, and that's wonderful. But Evan, I hear you screaming internally, only I can see this. What good is that to me? Well, they've also given us a handy little link to share with people. And you can use things like bit.ly or 3D or any link shortener to hide this link from suspicion. You can simply put the link in an email by highlighting it and clicking the link button. And once someone clicks on it, they think it's perfectly legit anyway. Suddenly they're executing something you want them to do. To talk a bit about persistent access, the cross-site scripting, that's how they abbreviated it with the X for cross. I honestly don't know what you're behind that. But this one's a little bit more dangerous because it persists and it's permanent and everyone sees this. Like, it's not just you anymore, it's now the entire site. So this concept, imagine you have a mini Twitter. Like, you have this little Twitter for you and your friends, you're talking away, and it's just a form where you put in your post and talk about the coffee you had this morning or your lunch, and maybe you can post a picture or two, and someone could log on later and tell you how much better their coffee was, and they had croissants from Paris flown in by Belgian Air or something. And that's nice and all, but they've still got this form again. And this time it's tied to a database, because that's the only way to make it permanent, is to actually have this stored somewhere in this little library of information, so that later when you log on, you come back and everything's there. And that was the second example to show you. So we can do the exact same thing again. We can just do underline, sanitization. Actually, you know what? Koalas. I like koalas. Oh, this one doesn't come with handy interaction. But yeah, you can see it's underlined again, and we can execute all of our HTML again. But this one's a little bit smarter. This one actually strips out the script tag. So if I try to put in script alert or script confirm as I did before, nothing will happen. Or at least it shouldn't. No, yeah. So they are getting smarter, and they're getting much better at kind of defeating us at this point, this imaginary person I've thought of. And if we refresh the page, it's still there. Just in case you didn't believe I pressed F5. But anyone can log on and see our wonderful information. But there's something else we can do, and it's actually still quite easy to get our script in JavaScript executing. It's not even that much more difficult. We just add a little bit to the start and maybe a tiny couple characters to the end, and it's very easy. So in this case, what we're doing is we're putting an image on a website, which sounds pretty normal, people do that from time to time. But a sort of relic from HTML, because HTML isn't actually that HTML4 isn't that old at this point. But a relic is these inline handles. So a handle is just it's just an event that happens that you can trigger something on. So other events would be on hover. So every time you hover over a box or an image or something, it could pop up and show you a much larger image. Or you have on click, which obviously on click will do something. And in this case, what we're going to do is we're going to use on error. So whenever an error occurs with this image, it's going to alert, which is just like the confirm dialog I just showed you, with just a pop-up with any empty message we want. And pop-ups are actually much scarier than you think. For instance, when I was in my 5th year in primary school, our entire Windows system was running like 2000 or something. So there was this net send command. And what you could do is you could send a message to any computer address, and it would pop up with that message, and you'd have to click OK to get rid of it. So I was messing around, and I hadn't intended to do this, but I put in just an asterisk, which is a wildcard, which means everything. Send it to everyone, no matter what. Anyone who can reach on the network, pop up with this thing. And I thought, that's not too bad, only people who are logged on, you know, until suddenly I realized all the notice boards in our school are electronic and hooked up to this system. All of our teachers' computers, the principal's computer, the vice principal's computer, and all of the displays that control our heating, control the water in the entire school, they all now have this message popped up in them, which is nothing is real, get out. You can imagine the kind of trouble I was in at that point. So what we are doing in this situation, because I just realized I never explained how we're actually generating the error, is an image always has to have a source. It has to come from somewhere, obviously. So what if we just don't give it a source? What if we just say nothing? Now every time that image is loaded, it's always going to generate an error. So it's always going to generate our code. We get another pop-up, and this is great because it's scary to people. You can extort so many people this way by just popping up something and giving them a link to some ransom notice. My mother thinks that pop-ups, legitimate pop-ups from like Twitter and stuff, like you know the one where it's like you click tweet and it pops up with write out your tweet. She thinks those are hacking her computer. Like, I don't understand it sometimes. But preventing cross-site scripting is it's easy enough, to be honest, because there's a lot of pre-made functions and methods in languages you use for the web that will automatically strip out and encode HTML and script tags and stuff for you automatically. Another method is just whitelisting everything you actually want to allow on the website. Because, you know, if you have a comment system, you might want them to do bold and italicize and underline and whatever. But you can then automatically, again, strip out the script tags and all the handles and everything. It secures your code and makes sure that some guy who's Googling for comment boxes doesn't write a script and go through all of the comment sections on your website and just destroy your post by randomly redirecting it to Meatspin or YouPorn or some dark web Silk Road type shit. Just gonna take a moment. I'm sure you'll be glad that this is kind of like the last leg of section I'm doing. So cross-site request forgery is a bit of a mouthful, but what essentially is it is what its alternative name is, session surfing. So what you're doing is you're hijacking sessions again. But you're doing it to get that person to unknowingly commit an action they don't want to do. So generally what will happen is someone will be logged in, you'll send them a link to what's called an API endpoint. So this is just something that has an action tied to it. So when the person visits that website, they go through that action and it gets performed and, you know, horrible things happen. So let's say we have this website, bank.com. It's pretty simple. It just allows people to take money from one account and transfer it to another, providing they're logged in and it's their account they're transferring from. But unfortunately, Billy and Maria have had a poker game recently, and Maria is pissed. Maria wants all of Billy's money. So she goes on to this website, which they're both part of, and it's how she paid the winnings to Billy. And she realizes that every time she goes to transfer, it goes to this URL with these parameters or options, and she could just send him a link for that. It just seems incredibly easy, doesn't it? But wait, she thinks, Billy's too smart. He's not going to click a link in a dodgy email. He's not going to give away all his money that easy. So she thinks to herself, and she kind of comes up with a solution. She thinks, aha! Every time an image is loaded, it has to make a request to a source. So she sends him an email with an image in it, but the image doesn't link to an image file. It links to this this URL, which transfers 100,000 euro out of Billy's account, whether he has it or not. And just by opening the email, he's already committed this atrocity. I'm also at liberty to explain right now that Gmail automatically strips out things like this. Actually, they're very good at protecting their users from attacks like this. You'll probably get more of the variety of phishing, trying to socially engineer you to clicking a link, than you will opening an image. I don't want to put the fear of God into you about opening your emails anymore. Although I'm sure a lot of you would love an excuse. So this is actually my second last slide. Preventing CSRF is a lot more complicated than the other two, just technically speaking. In terms of concepts, it's very simple. What you do is you have a unique token on either end of a request. So when you're at a form, there's a secret hidden token that says you are you, and it's this time, and it's got a life sentence. You know, after a certain point, it expires and it's gone. You can't use it again. So if someone gets that token, they can't use it as you. But then you also have something on the other end to verify that the token that went through the request is totally okay too. Saying it out loud doesn't actually sound as simple as I thought it did, but programmatically that's a lot harder to kind of implement in a very secure way. Because honestly, by God, if you go and make web applications, try very hard never to expose a token unless you're absolutely damn sure that it is unique, cannot be replicated using any time signatures, and is obfuscated to the point where you can't tell someone's user information from it. Because I know people like, some people try to get around it by putting like the user ID at the end, but instead of actually helping themselves, they suddenly gave the hacker another point of entry, because it now knows something about your schema and how you dictate user entries, their user IDs, and that can be just as scary. Oh yeah, and you can also provide a secondary authentication for very sensitive tasks. So if like you're about to delete your account, you should probably ask them, are you sure you want to delete your account? And probably ask them again, are you absolutely positively sure you want to delete your account? And then pretend there's an error and don't delete their account. That's how you keep users, that's user retention business. Okay, so we're at the Q&A. If you have any questions, you're more than welcome to ask them now. I'll try my best to answer them. If not, Mervin's going to do a wonderful little demonstration of certain vulnerabilities using OWASP's software. So, no? Cool.
Yeah, we don't do Wi-Fi with Mervin, so.
Sure. Oh, okay. We got an impromptu speaker.
Yay!
Right.
Get that running on the server every time somebody goes to the page. You know, it's we can do like anything that the
go to
server
a
user could
cafe
do.
or whatever, see there's a Wi-Fi hotspot available and connect to it without even thinking about security. I would gather probably most of you, because it's not really on your mind most of the time.